Sorry about that. The particular recording software that I'm using only allows 10 minutes of recording unless you purchase the pro version of it. So as I was saying, the attenuation. The attenuation is the loss of energy. When a signal travels through a medium, it can lose its energy. For example, if a signal travels through the atmosphere, there are factors like the vapor or the dust which can lose the signal's strength. And also, if a signal is sent through a fiber cable, and if the fiber cable is bent in certain areas due to certain angles, the signal could be lost as well. So, an amplifier can be used to boost these signals, which can compensate for the loss of the energy of the signal. To show that a signal has lost or gained its energy, decibel can be used, which is denoted by dB. If there is a negative value of the decibel, that means the signal has lost its energy. And if there is a positive value, that means that the signal has been amplified. Distortion. Distortion is when the form or shape of a signal is changed. For example, a composite signal, which is a collection of many sine waves. Each sine wave has its own delay and its own transmission speed. So when and each signal will have its particular delay. So when all of these signals come, when each of these signals arrive in delay, the final composite signal will have a delay as well, and will not be the same shape of the signal which was originally sent. Noise. Noise is an unwanted signal added to the original signal, mainly due to the movement of electrons. There are several types of noise, which can be thermal noise, induced noise, and also impulse noise. Digital signal transmission. Digital data into digital signals. Line coding. Line coding is the process of converting digital data into digital signals. Data in the computer memory, for example, images, audio, are stored as a sequence of bits. Line coding converts this sequence of bits into a digital signal. At the sender, the digital signal, which is encoded and sent, the digital data which is encoded and sent as a digital signal to the receiver. The receiver converts the signal which is received back to digital data. Line codes can have elements, data and signal elements. Data elements are pieces of information that need to be sent, and signal elements are what carries these elements. The goal is to increase the data rate, which decreases the signal rate. The baud rate determines the required bandwidth for the digital signal. When the average voltage of a digital signal can be 0, this can be a problem for a system that doesn't allow low frequencies. Some commonly used line coding schemes are RZ, NRZ, AMI, 4B, 5B, Manchester, and differential Manchester. Sampling is the process of sampling the signal so that the original signal can be made out of the sample signals. If you refer the diagram below, this is a 1 second long analog signal which has been sampled for 26 times. Using this samples, we can make the analog can make the original signal by combining these samples. When quantizing, we need a finite set of values which can be converted to binary values. if we use 8-bit depth to measure the samples. 8-bit depth is the number of bits in each sample. So if we use 8-bit depth to measure the samples, according to this particular example in the diagram, it means there are 256 levels. Each horizontal line represents each level. Each level has its own bit value. We match each sample to each level because each level has a specific binary value. That this is quantization. And lastly, encoding. Encoding is converting each sample from right to left in time order to specific binary numbers. From 1 second of analog signal, we can get a long stream of zeros and ones, as you can see in the diagram in the example shown. This particular example is used to show only one signal, only 1 second of an analog signal. Those are the three features of the PCM. Next, we will talk about the digital signal transmission. Transmission modes. When we consider the transmission of data from one device to another, the concern is the wiring. The data stream sent through the wiring is to be concerned about. Is one bit sent at a time, or is a group of bits sent at a time? Binary data can be transmitted in parallel or serial. In parallel transmission, binary data is arranged into groups of bits. Computers use data in groups of bits, just like humans use words and not only letters. The advantage of parallel transmission is that each bit will have its own wire, so there will be a high transfer speed. But the disadvantage is that it requires a high number of transmission lines for a short distance, which can be costly. In serial transmission, one bit is followed by another, so there is only one communication channel used, not many lines like in parallel. Serial transmission can be asynchronous, synchronous, and asynchronous. In asynchronous transmission, the timing of the signal is not important. Information is received and transmitted by an agreed upon pattern. As long as these patterns are followed, the receiving device can retrieve the signal. In synchronous transmission, we send one bit after another without any gaps or stopping. The receiver should group these received bits. And in asynchronous transmission, the groups of bits are synchronized, so they arrive at a fixed rate. An example for this synchronous is when watching TV. Sending a digital binary stream or an analog channel can have three ways, which is ASK, FSK, and PSK. First, the ASK, which is amplitude shift keying. This is when the digital signal changes the amplitude of the carrier wave. If the digital signal value is 1, then the carrier wave stays the same. If the carrier wave value is 0, the amplitude is much weaker. And in FSK, which is frequency shift keying, when the digital binary value is 1, the frequency is the number of times which a cycle repeats. So the frequency of the carrier wave is high, and when the binary value is 0, the frequency would decrease. And as you can see in PSK, which is phase shift keying, when the binary value changes from 1 to 0, the phase will change. And again, when the binary value changes from 0 to 1, the phase will change again. These are the three digital modulation methods.